So this is for class 10 students, polynomials chapter. The topic is geometrical meaning of zeros of a quadratic polynomial. See, you can see this is a curve, U-shaped curve. So this U-shaped curve is always represents a parabola. Parabola. And remember, quadratic polynomial, the shape of graph of the quadratic polynomial is always a parabola, that means U-shaped. Now this parabola is nothing but the quadratic polynomial. So this I will write general form of quadratic polynomial, ax square plus bx plus c. This is general form of quadratic polynomial. So graph of this quadratic polynomial will be like this always. Okay. So we are discussing geometrical meaning of zeros of a quadratic polynomial. Geometrical meaning means graphically on the graph what is the meaning of zeros, like that is a geometrical meaning. Geometrical meaning of zeros means graphical meaning. I mean from the graph what is the meaning of zeros. Okay, that is a headline, geometrical meaning of zeros. Now remember this, I have taken an example, random example. I just roughly drawn the curve. Now zeros means, remember the x values at which the graph or curve cuts the x axis. See, this is x axis and this is y axis. Okay. So where is the curve cutting the x-axis at which points? Here, right? So this is x-axis. So this curve is cutting here and here. Okay. So here also the graph or curve is cutting, but this is y-axis. Y-axis. To identify zeros, we have to see only x-axis. See this curve cutting this x-axis at 2 points, -2 and 3. So we will take, since these -2 and 3 are present on x-axis, we will take x is equal to -2, x is equal to 3. Okay. Now these are called zeros. Okay. You got it right? What is the geometrical meaning? The graph or curve that cuts the x-axis at 2 points. This parabola cuts at 2 points. So those two x values are called as zeros. Okay. So that is the meaning of zeros. So if somebody asks what is geometrical meaning of zeros, means the graph of a function or polynomial where it cuts on the x-axis. So those 2 points represent the zeros. Okay. In other words, I can say the values of x at which the curve cuts the x-axis are called as zeros. So these are the zeros. In simple words, just remember, just see where the graph cut, at which points the curve is cutting the x-axis. So those 2 points will be the zeros. Okay. Points means, remember, x values only x values. You have to consider the values on the x-axis only. Don't consider this -3. See, this curve is cutting here also, but -3 is not 0 because this is y-axis. At this point, this curve is cutting the y-axis. Okay, but zeros means we have to see where the curve cuts the x-axis. Okay, so the minus 2 minus 3 are the zeros. This minus 3 is not 0, it is wrong, because zeros will exist only when curve cuts the x-axis. Simple. Next topic, is three cases three cases three cases about the shape of graph of parabola. There are three cases. One is graph cuts x-axis, cuts the x-axis at two distinct points. So there are three cases about the shape of the graph of the parabola. This is first case. Graph cuts the x-axis at two distinct points. First I will write the graph. See, parabola can be U-shaped, like upwards, or it can be downwards U-shaped. So both are parabola, and both this and this represents a quadratic polynomial. This U shape can be upward, this U shape can be downward. Still, this is also parabola, this is also parabola. This also represents the quadratic polynomial. Even this also represents the quadratic polynomial. So what is the case 1? Graph cuts the x-axis at two distinct points. So this is x-axis, this is y, this is x, this is y. Distinct means different. Okay, different points. See, this is x-axis. See, the curve is cutting x-axis here and also here. So this is different point, this is also different point. This point are not same. They are both are different points. So see, this graph cutting the x-axis at two different points. Even here also, this graph cutting this x-axis here and here. Okay. So this is what the meaning of graph cuts the x-axis at two distinct points. Now we can see, when curve cuts the x-axis at 2 points, two different points, then this graph or this graph have two zeros. Okay. Simple. If a curve cuts the x-axis at two different points, then that function has two zeros. Why two zeros? Because it's cutting the x-axis at two different points. This is one point, this is another point. At two different points, it's cutting the x-axis. So two zeros. Two different points, two zeros. This have two zeros, even this has two zeros. Okay. Now case 1 is finished. Next I'll move to case 2. Now I will explain you the case 2. So I will just rub the thing, anything, any previous content if you want to see, you can just move the video backward. Okay. Graph cuts the sorry, I forgot to add here x-axis. X-axis, okay. Graph cuts the x-axis at exactly one point. Exactly one point. I will draw the graphs so you will understand. Two graphs I will draw. Okay, this is actually parabola U-shaped. I'm just drawing rough diagram, okay, but this is U-shape. Next, another graph. So, see what is the headline? Case 2 is graph cuts the x-axis at exactly one point. So this is x-axis, this is y-axis. Graph means this curve. You can see this curve is cutting this x-axis at only one point. Exactly one point. In previous case we have seen the curve was cutting the x-axis at two different points, correct? Here you can see it is cutting the x-axis at only one point. Even here, so this graph or this curve is cutting this x-axis. This is x-axis at only one point. One point. Okay? So that is the meaning of this. Graph cuts the x-axis at exactly one point. Correct? So since this curve is cutting the x-axis at only one point, so though this curve has 1 0. Only 1 0 it has. Okay. Why only 1 0? Because this curve cutting the x-axis at only one point. At only one point it cutting the x-axis. So 1 0. Even this also. So this curve is cutting the x-axis at only one point. See, because of this one point, how many zeros it has? 1 0. Okay. Now this function as 1 0. Even this function has a 1 0. Because cutting the x-axis at only one point. Okay. Next I will move on to case 3. This is case 3. Graph is completely above or below. The graph is completely above or below the x-axis. This is case 3. I will draw the diagrams first so you will understand. This is So this is x-axis, this is y-axis, this is x-axis, this is y-axis. Now this U-shaped curve is parabola. Even this U-shaped curve is parabola. So these are not exactly U, but I have just roughly drawn the diagram. So assume these are exactly U-shaped. Okay, U-shaped curves. So this also parabola, this also parabola. See, what is case 3? Graph is completely above or below the x-axis. You consider the first graph. This is first graph, this is second graph. So this is x-axis, right? You can see this curve is not cutting the x-axis, correct? It is not even touching the x-axis at any point. It is just above. See, this is x-axis. This curve is just above the x-axis, and it is not cutting the x-axis. Okay, here this is above. The curve lies above this x-axis. That means it is not touching x-axis and it lies above the x-axis. Here you can see this is x-axis. This curve is not touching or cutting this x-axis, and you can see it lies below, right? This is x-axis. If it lies here, this is above. If curve lies here, this is below x-axis. So this is x-axis. This curve is present below this x-axis. Below this x-axis, and this curve is not touching the x-axis at any point. Okay? So that is the meaning of below. Below the x-axis. Okay? You understood, right? The graph is completely above or below the x-axis. That means the curve is not touching the x-axis. Even here it is present above the x-axis. Here it is present below the x-axis. Okay, this is case 3. You understood, right? Now what about the zeros here? Remember, zeros of a function exist only when the graph of the function or graph cuts the x-axis or it touches the x-axis. Okay? If curve cuts the x-axis, then only there will be zeros. Okay? But here the curve not touching or cutting the x-axis, even here also. That means no zeros. So this also no zeros. This function also has no zeros. Even this also no zeros. No zeros. Both this and this function or graphs have no zeros at all. Why? Because these curves are not touching x-axis. Only if curve touches or cuts the x-axis, then only there will be zeros. It cuts the x-axis at one point, then there will be 1 0. If it cuts the x-axis at 2 points, two different points, then there will be 2 zeros. But here it is not cutting x-axis at all, so that means there are no zeros. Okay. So that's all about 3 cases of the parabola and the number of zeros. Okay. Thank you. Anything if you want to say, you can please mention the comment. Okay. And subscribe.